Welcome to this session. This session, we are going to study about tangent planes to a surface. So let f of x, y, z equals to 0 be the equation of a surface S. Then the equation of a tangent plane to the surface is given by x minus x1, equation of a tangent plane at the point x1, y1, z1 is given by x minus x1 partial f partial x plus y minus y1 partial f partial y plus z minus z1 partial f partial z equals to 0, where partial f partial x partial f partial y partial f partial z are the direction ratios of the tangent plane. So this is how we define, or how we find the equation of a tangent plane to a surface S, whose equation is given by f of x, y, z at a point P, x1, y1, z1. You simply get the partial derivatives of the surface with respect to x, with respect to y, and with respect to z, and then you put into this formula. These numbers, partial f partial x, partial f partial y, partial f partial z, are called direction ratios of the tangent plane. Then there's what we call the normal, equation of the normal to the plane. The equation of the normal to the plane is given by x minus x1 divided by partial f partial x equals to y minus y1 partial f partial y equals to z minus z1 over partial f partial z. So where the equation of the normal through the point x1, y1, z1. Or you can put this one in parametric form. In parametric form, if I call this one 1, and I call this one 2, 2 becomes x equals to x1 plus partial f partial x, then times t, y equals to y1 plus partial f partial y times t, and then z equals to z1 plus partial f partial z times t, where t is a parameter. So let's see an example. Find the equation of the tangent plane and normal line to the surface defined by x squared plus 2y squared plus 3z squared equals to 12 at the point 1, 2, minus 1. So what we have to do is to get this equation of the surface as f of z, x, y, z. So given this equation solution, we have x squared plus 2y squared plus 3z squared. Now you bring 12 to the left equals to 0. So therefore, what we call capital F of x, y, z is this left-hand side expression. So therefore, the equation of the surface can be given, can be written as x, f of x, y, z is x squared plus 2y squared plus 3z squared minus 12. So partial f, partial x will be given by 2x, and then which implies partial f, partial x at the specified point 1, 2, minus 1 is 2 times 1, which is 2. And then partial f, partial y will be 4y, which means partial f, partial y at the point 1, 2, minus 1 is 4 times 2, which is 8. And then partial f, partial z, when you differentiate this function with respect to z, you get 6z, which means partial f, partial z at the specified point 1, 2, minus 1 is 6 times minus 1. So this is the value of z, you get minus 6. So then, equation of tangent plane is given by x minus x1 partial f partial x actually at this point x1, y1, z1 plus y minus y1 partial f partial y at the point x1, y1, z1 plus partial f partial z, then is a coefficient z minus z1 partial f partial z at x1, y1, z1. So remember the point we were given is 1, 2, minus 1. So this corresponds to x1, this one y1, this one z1. So I'll have x minus 1. And then the partial derivative of f with respect to x at the specified point, the answer was 2, plus y minus 2. Partial f partial y at the point was 8, plus z minus, so this was -1, so minus minus plus 1. The value here, partial f partial z at the point specified is -6. Remember this, you equate to 0. This equals to 0. So this should be 0. So 2x minus 2 plus 8y minus 16, and then minus 6z minus 6 equals to 0. So we'll have 2x plus 8y minus 6z minus 2 minus 16 minus 18 minus 6 minus 24 equals to 0. So we have, and then this 2 is a common factor, so you can divide through by 2. So divide through by 2, by 2, by 2, by 2, by 2, so that we have x plus 4y minus 3z minus 12 equals to 0. Or you can say x plus 4y minus 3z equals to 12. So that is the equation of the tangent plane. Now normal, equation of the normal is given by x minus x1 over partial f partial x at the specified point. So at x1, y1, z1 equals to y minus y1 partial f partial y at x1, y1, z1 equals to z minus z1 divided by partial f partial z at x1, y1, z1. So we'll have x for x1 is 1, and then partial f partial x at the point was 2, and then y minus 2 partial f partial y was 8, and then z plus 1 over minus 6. Which is the same thing as saying, because these are common factor too, so you have x minus 1 over 1 equals to y minus 2 over 4 equals to z plus 1 over minus 3. Or in parametric form, you can write the equation as x minus 1 over 2 equals to y minus 2 over 8 equals to z minus z plus 1 over minus 6 equals to t. So you multiply through by, so x minus 1 over 2 equals to t. So this will give us x equals to 2t plus 1, and then y minus 2 over 8 equals to t. The same thing as saying y equals to 8t plus 2, and z plus 1 over minus 6 equals to t is the same thing as saying z equals to minus 6t minus 1. So you can decide to write the equation in this parametric form, or just write it in this other form. So that's how we solve that problem.